My name is Darren Thomas. I'm the Director of Educational Research Techniques, and we're finally now in Unit 3. We're going to take a look at ridge regression. This is simpler, learning how to use machine learning algorithms in R. So this particular unit has 4 videos to it. We're going to take a look at, we're going to provide an overview of what ridge regression is and the machine learning process. That's what we're going to look at in this particular video. Then we're also going to take a look at data preparation. We've done this before, and model development, and finally model testing. So having said that, why don't we go ahead and get right into Unit 1. So we're looking at ridge regression, what it is, and I'm going to talk a little bit about the machine learning process, because as we go forward over the next few chapters, the process or the approach that we take is going to be slightly different from the prior chapters, because what we're trying to do now is we're trying to compare different models based on a training set and a test set. We're doing a basic approach to machine learning data science, if you will, for model testing, but I'll explain that more in a second. So ridge regression is, again, traditional regression, but with a slight twist. What we have now is we have something called, I hope you can see this right here, regularization, which involves a shrinkage penalty in order to reduce the residual sum of squares. Now, one of our primary goals in developing linear models is to reduce error, to reduce the residual, if you will. And the shrinkage penalty is applied to try to reduce this. And you do this by tuning a hyperparameter called lambda. Now, here's the thing. A hyperparameter is a parameter that an algorithm cannot learn by itself. In other words, you as the researcher, as the data scientist, have to manipulate this by using different values to determine what the best hyperparameter value will be for that particular algorithm. Different algorithms have different hyperparameters that affect the performance of the model. And so when we're dealing with ridge regression, when we're dealing with regularization, if you will, the hyperparameter in this particular context is called lambda. Now, there are 3 benefits to this, and I know I'm moving quickly, but you have to keep in mind that we're not going to go over the mathematics of machine learning. Instead, what we're going on, we're focusing on the application or the use of the algorithms. So moving back to my point, there are 3 primary benefits of regularization, of using ridge regression and its brothers, lasso and elastic net. So the first one is computational efficiency. You don't have to make multiple models. Instead, you make one model and you apply the lambda, and it saves you time. Remember, one of the problems with best subset regression was you had to make all the potential models and then calculate which one had the lowest residual sum of squares based on the different criteria you might have used, whether it was Mallow CP or whether it was Bayesian information criterion. A second thing is that it helps to deal with the trade-off between bias and variance. Variance is when the model is kind of wild depending on the data set, whereas bias is kind of like the model is not too responsive to changes in the data set. And so you want to try to find that middle ground, if you will. And one of the last main benefits, of course we could talk forever, is that it helps to eliminate multicollinearity, because the lambda is able to reduce some of the coefficients down to 0, which is almost 0, not exactly 0, close to 0. It's almost like a limit function in calculus, if you will. And so what's happening is that because you're able to reduce coefficients that are not very useful almost to 0, not exactly to 0, it helps to remove multicollinearity, because many variables are almost removed from the model, but not quite. I hope that makes sense. It will as we apply it. Now, what's happening, and this is for those of you who are a little bit more comfortable with mathematics and calculus, because statistics has a lot of calculus going on behind the scenes, is that this is essentially our L2 norm. Now, norm in calculus means it shrinks it down to an absolute value, some sort of a positive value. And what's happening is that we're doing the residual sum of squares plus lambda times the normalized coefficients that are squared. Again, this is what the computer is doing when it is taking each independent variable and lining it up with the dependent variable. And like I mentioned before, it can shrink coefficients near to 0. In other words, whereas best subset regression will recommend to remove certain variables, ridge regression will basically lower the coefficient of the least useful variables almost to 0. So this is kind of what's happening there. And so in this particular unit, we're going to be focusing on how to apply this and how to use it for making models. Now, the next thing I want to explain to you is the process of data science, of machine learning building models. So before, all we did was we basically made a model and we checked the assumptions, if you will, and that was essentially all that we had to do. But now what's happening is that with going more into a data science paradigm, going more into a machine learning paradigm, there's a specific process that you have to do. What we're going to do now is that, yes, we're going to continue to prepare the data. We've done that before. But now what's going to happen is we're going to split. We're going to split our sample, our data set, into two parts now. One part is going to be for training the model. In other words, for the training data set, you are able to run models over and over and over again and try to find the model that works the best within the training set. But then once you are satisfied with what you've done with the training set, you test the model with a different set of data. So you start, in other words, you start with the full set of data like this, and generally we do like a 70-30 split, so I guess something about like this. So 70% here, 30% or 70-25, it all depends. And with this part right here, you are training your data set, trying to get a sense of how it's doing. And then with this last 30% of the data, you test. That's what you're trying to do. And you want to try to find the best model based on your training data. Now, this is not the only way to do this. I need to clarify that. This is the most simplistic approach that you can take for training the model and then testing the model. And then once you test the model, of course, you have to pick some sort of a criterion. So we're going to normally use the mean absolute. What is it called? The absolute mean value. I forget the actual criteria. We'll cover that in the future chapter. But the absolute squared mean, the mean error, absolute error, mean absolute error. Absolute error. So we're going to be looking at absolute error, and you want that value to be as low as possible. And so how you know which model is the best model depends on the one that has the lowest mean absolute error. That's what we're going to be looking at. And so you make several different models, and then you test one time. If you continue to use the test set over and over again, what happens is that you begin to train your data on the test set. And so you don't get the best results. You want to use the test set once, because in general you want to use it once, because what happens is that you use the test set to see how your model will generalize to future data. That's what you're trying to do there. So that's pretty much it for this particular video. We're going to be taking a look next at data preparation in a few moments. And I'm going to walk you through that, and then we're going to start developing the model. So in this particular video, we talked a little bit about what exactly ridge regression is, how it uses the L2 norm, how it penalizes coefficients and reduces them almost to zero for the sake of improving the predictive accuracy and power of the model. And then after that, we talked a little bit about the data machine learning process, in which you are learning about how to prepare the data and how you have two primary steps when it comes to model development in the machine learning paradigm, the data science paradigm. You have training the model on a piece of the data set and then testing the model on another piece of the data set to see if your model generalizes. So my name is Darren Thomas. I am the Director of Educational Research Techniques. This is Simpler, and we're trying to understand how to use machine learning algorithms in R. Thank you.